Hi friends, welcome back to another interesting question. We are asked to calculate the size of this angle A. This is a square-shaped quadrilateral. We have a circle and a semicircle in it. So how can we solve this? How can we calculate the size of this angle A? It is very simple. Come to this square here. We know a square has all four of its angles to be right angles. That is, this angle, this, and this are right. Look at this triangle. It is a right angle triangle. Let's assume the length of this side to be 2 units. We use the circle tool on it. Taking this angle as theta, this is the opposite and this is the adjacent. So theta equal to A, opposite equal to 2, and adjacent equal to x. From here, TOA means tan theta equal to opposite of our adjacent. Substitute these values here. So tan A equal to 2 over x. Come to the semicircle. Obviously, this side is its diameter. Diameter is 2 radius. But from the figure here, there is a circle and a semicircle. Each will have its unique radius. So we let radius of semicircle be y and that of circle to be z. So here, this diameter is 2y. Therefore, x equal to 2y. Substitute it here. So tan A equal to 2 over 2y. 2 eliminate 2. So tan A equal to 1 over y. Come here. Replace the x's each with 2y. We see this side touch the circle at this point. That makes it a tangent. And this also touch the circle. That implies that it is also a tangent of the circle. From the circle theory, there is this rule that the tangent of a circle is perpendicular to its radius through point of contact. So here, if we draw out the radii z's, the angle they'll form with the tangent are right angles. Let's look at this quadrilateral. 3 of its angles are right angles. The only 2 types of quadrilateral which has up to 3 of its angles to be right angles are the rectangle and the square. But here we have this side and this to be adjacent and equal. That is only possible for a square. So the quadrilateral is a square-shaped quadrilateral. A square has all 4 of its sides to be equal in length. So since this side is z in length and this is 2, we can say z equal to 2. That is, the radius of this circle is 2 units. Come back to this semicircle. Draw out the complete circle. Now we have 2 circles, a large one and a smaller one. They both touch at this point. From the circle theory, there is a rule that if 2 circles touch at a point, their point of contact lies on the straight line that connects their centers. So this point of contact lies on the straight line that connects this center and the midpoint of this diameter. This is a radius of the small circle, and this is a radius of the large circle. Come here, from this point, draw a straight line parallel to this side to intersect this line. Since it is parallel to this, which is perpendicular to the radii, this new line will also be perpendicular to the radii. Look at this quadrilateral. All its angles are right angles. That makes it either a square or a rectangle. It doesn't matter which one it is. In both a square and a rectangle, opposite sides are equal in length. That is, this side and this are congruent, and this are equal. So since this is 2, this must also be 2. And if we let this be V, this must also be V. But this is a radius of the large circle. So since this part is 2, this must be y minus 2. Look at this triangle. It is a right angle triangle. We can use the Pythagorean theorem on it. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. So by Pythagoras, y plus 2 all squared equal to y minus 2 all squared plus v squared. Y plus 2 all squared is y plus 2 times y plus 2, which is y times y plus 2 times y plus 2. Y times y plus 2 is y squared plus 2y, and 2 times y plus 2 is 2y plus 4. 2y plus 2y is 4y. So it is y squared plus 4y plus 4. This also, if we extend it, it is y squared minus 4y plus 4. So y squared plus 4y plus 4 equal to y squared minus 4y plus 4 plus v squared. This 4 eliminate this 4 on the left. This y squared cancels this y squared. This negative 4y, take it to the left. 4y plus 4y is 8y. So 8y equal to v squared. Take the square root of both sides of the equation. Here, square root of v squared is v, while here, square root of 8y. Since 8y is 4 times 2y, square root of 4 times 2y is 2 times root 2y. That is 2 root 2y. So v equal to 2 root 2y. That is, the length of this side is 2 root 2y. The whole line segment, its length is 2y, but it is divided into this 2 root 2y and this 2. So we can say 2y equal to 2 root 2y plus 2. Take 2 to the left hand side of the equation. So 2y minus 2 equal to 2 root 2y. Square both sides of the equation. Here 2 root 2y all squared is 4 times 2y, which is 8y. 2y minus 2 all squared is 2y minus 2 times 2y minus 2, which is 2y times 2y minus 2 minus 2 times 2y minus 2. 2y times 2y minus 2 is 4y squared minus 4y. Minus 2 times 2y minus 2 is minus 4y plus 4. Minus 4y minus 4y is minus 8y. So it is 4y squared minus 8y plus 4. Bring this 8y to the left. Minus 8y minus 8y is minus 16y. So 4y squared minus 16y plus 4 equal to 0. Multiply through by 1 over 4. Here 4y squared minus 16y plus 4 multiplied by 1 over 4 is y squared minus 4y plus 1. So y squared minus 4y plus 1 equal to 0. This is a quadratic equation. By the quadratic equation formula, any equation in the form ax squared plus bx plus c equal to 0, x equal to minus b plus or minus root of b squared minus 4ac all over 2a. Compare this equation to this, we'll obtain x equal to y, a equal to 1, b equal to minus 4, and c equal to 1. Substitute it here. So y equal to minus into bracket minus 4 plus or minus root of minus 4 all squared minus 4 times 1 all over 2 times 1. Minus 4 is plus 4. Minus 4 all squared is plus 16. Minus 4 times 1 is minus 4. 16 minus 4 is 12. 12 is 4 times 3. Square root of 4 times 3 is 2 root 3. 2 times 1 is 2. From 4 plus or minus 2 root 3, we can factor out 2. So it is 2 into bracket 2 plus or minus root 3. This 2 cancels this 2. So y equal to 2 plus or minus root 3. That is y equal to 2 plus root 3 or y equal to 2 minus root 3. Which is the right solution for the subject? Y is the radius of this semicircle, and that of this small circle is 2 units. 2 minus root 3 is less than 2, and there is no way that the radius of this is larger than that of this. So we discard this. Therefore, y equal to 2 plus root 3. 1 over 2 plus root 3. Multiply it by 2 minus root 3 all over 2 minus root 3. 1 times 2 minus root 3 is 2 minus root 3. And 2 plus root 3 times 2 minus root 3 is 4 minus 2 root 3 plus 2 root 3 minus 3. Minus 2 root 3 plus 2 root 3 is 0. 4 minus 3 is 1. So tan A equal to 2 minus root 3. If we take the tan inverse of 2 minus root 3, it is 15 degrees. So A equal to 15 degrees. Thank you for watching. Please like, share, and subscribe, and also turn on notifications. Thank you.